Hello, this is Charlie Pellerin again. This is segment 2 of my narrations of our 3-day workshop slides. Welcome back. This is a particularly interesting segment to me because we get a deep insight into the role of social context when we look at the major colossal failures. And by the way, you don't have to be involved with projects like this to care about this material. What I'm saying here is that many smaller problems erupt in projects and organizations and management teams of all sizes. Just when something gets really big, there's no end of the effort to find out what caused it. Whenever people look deeply enough, it's always a social context at root cause, not a technical problem. So we're going to take a look at the explosion of Space Shuttle Challenger. And we're going to look next at the something I had very close intimate familiarity with, the Hubble's mirror flaw made the telescope useless. Interesting thing about Korean Airlines, it was crashing for years at 17 times the international norm. And what's fascinating to me about this case study is why it went on so long. It's the same error people make all the time, over and over. They mistake individual capabilities as being the driver when it's social context. And then the explosion at the power plant at Fukushima Daiichi plant number 1 in Japan, I think you're all familiar with that. We'll take a look. I like to describe and illuminate difficult social ideas with familiar technical metaphors. So we're going to use a magnetic field as a metaphor for a team social context. Let me show you something I find rather remarkable about this material. In fact, maybe the most amazing thing of all is that we are, in effect, developing leadership in team members en masse, all at once, all at the same time. Nothing else in the world is as efficient as this. We're going to have to stop and let you do an exercise that's about you again as we march up that green line I showed you in the last set. You're going to look at uncomfortable realities. For years I studied creativity, trying to find some key to it, and finally I read a book that actually wasn't very good by Robert Fritz, but he had one idea that was really amazingly powerful, and that is that the failure to confront uncomfortable realities is the primary obstacle to our creativity, and furthermore, once we learn to do that, creativity blossoms. I'm going to show you our basic learning process. We go through this over and over. AMBR, attention. I'll bring your attention to something you're not familiar to thinking about. Shift your mindset or attitude. You'll practice doing a behavior, then you'll get a good result. That's the process. This just summarizes where we've just been, the 5 forces, who we're here to change, our agreements, and the sharing you did to enhance your trustworthiness. Okay, good to go? Great, let's go. As I mentioned before, these are 4 colossals. There's lots and lots of others. These happen to be my favorites. Colossal failures that each one could have been prevented by prompt and proper attention, team social context. And if we'd had the tools that I used today and used them in each of these cases, I think we would have prevented these disasters. That's how powerful we are with these things. So Space Shuttle Challenger had also a special personal relationship for me. I drove into my parking lot in NASA headquarters in January 28, 1986, and people in my staff were waiting for me at the elevator. This never happened before, and I wondered why. And they ran up to me and said, Charlie, Challenger's exploded. Now, the reason they told me this was I had a low-cost payload in the cargo bay of Challenger called a Spartan. Here's an image of it on a different flight. It was a small payload, built very low cost, and designed to carry experiments on a standard carrier frame that's like a small satellite. The astronauts would pick it up, lift it out of the cargo bay, deploy it in free flight, back the shuttle orbiter away from it, let it do experiments for about a week as like a regular satellite, recapture it, bring it back, and we'd reuse it. So for a while I wondered whether we had cut the corners too close on this, and this very, very inexpensive satellite had somehow ripped out of its mounts and gone through the rather flimsy doors on the cargo bay of the Space Shuttle Orbiter and hit the boosters and caused the explosion. Well, as you know, it wasn't. It was a failure of the solid rocket motors themselves. So I'm watching the failure review board very carefully because of my interest in this, and also the fact that I knew very well many of the managers of the solid rocket motor system at Marshall. I'd worked with them on a project called Space Lab for many years. First-rate guys, top-rate technical managers, and I'm wondering what in the world happened. So I'm watching the failure review board, and this physicist Richard Feynman, who's a personal hero of mine, was on the board, and he reaches into his ice water glass with a piece of the O-ring material, cools it off, and shows how it's stiffened. Well, I looked at that and said, okay, I get it. The guys made a mistake with the thermal elasticity of the material, and the O-ring thing didn't analyze it adequately or properly. It's a technical mistake, end of story. It's most unfortunate that I stopped at that point, because had I paid more attention, I would have seen something that I only learned about years later, reading a book by a sociologist named Diane Vaughan, who was a member of the Failure Review Board. She didn't start off as a member, but they later added her. And the book was called The Challenger Launch Decision, and she said, the question is, why did they launch when all the evidence suggested otherwise? And as I look at this and ask, what was the fifth force? It was a political pressure to launch. Earlier, the NASA administrator, a man named Jim Beggs, had gone to President Reagan and gotten the shuttle named as the National Space Transportation System. So the pressure to launch on schedule was huge, and these guys had to do it. So they're being pressured to launch, and they descended into what she called normalization of deviance. Now, normalization of deviance is when a behavior that is obviously deviant in a larger context becomes normal and gets ignored. In the case of the Space Shuttle launch readiness team, what they hadn't realized was that they required an ever more persuasive technical argument to delay a launch than to proceed with a launch. She called it a drift into normalization of deviance. And we're going to talk a lot in this workshop about perception. I think it's the frailest of human capacities, and they perceived it as safe when it wasn't. By the way, normalization of deviance happens in our regular lives with things like discrimination against women or people of color, or even a simple case of Americans believing because house prices went up faster than gross domestic product for years at a time that they always would do it. It's obvious to anyone that thinks about it that's impossible. We're in the mess we're in now because of that. She goes on to say, Diane Vaughan says, it is most unfortunate these forces are invisible and unacknowledged. So it's a sad thing that my explanation is the right one, because you can never do anything about it. Well, I don't agree, and I'll show you later. And in today's language, what we would say caused the Challenger explosion is a flawed team social context put good people in a bad place. It's that basically that simple. That's what happened. Okay, social context caused the shuttle to explode, not the fact that the people weren't technically trained or experienced managers. No. Okay. Much closer to me was Hubble Space Telescope. As you may know, I was the program director for 8 years when we went down to the Cape to launch it. We worried a lot about whether the shuttle would get to the right orbit, and it did, perfect orbit. I went over to Johnson Space Center for the early operations and watched the check out of the telescope and agreed that we should release it into space, and the shuttle came back. Everything looked good. Things were looking fine. About 1 month later, I go to watch the first light image as we opened the aperture door for the first time and saw that the image was kind of blurry, and Hubble's chief system engineer was sitting next to me. And I said, Gene, that picture looks fuzzy. He said, oh, Charlie, don't worry. We didn't know exactly how the structure that holds the secondary mirror would react in space after a month or so. So we put the secondary mirror a little bit out in its focus, realizing that if we aired, we could drive the motor in only one direction. Very conservative program. It only takes about a week or two later to discover that what that fuzzy image was, it was a problem with the telescope at large. The telescope could not be focused. And I'll show you here a nearby galaxy called M100, Messier 100. The left-hand panel is the Hubble image. The center panel is an image with a very small 24-inch ground-based telescope. You can see what a horribly flawed telescope we had built. NASA's crown jewel is useless. Was the root cause a lack of individuals' technical abilities or a flawed social context? By now, I think you know. What kind of people do you think we had technically working on Hubble? Do you think we had a bunch of idiots, or do you think we had the best people in the world? And it was a worldwide project. No doubt, the best managers and technical experts in the world. So what happened here? When the mirror was fabricated, the way you do these mirrors is called an indeterminate method, and you see the actual flight mirror on a polishing machine. So the machine polishes for a while, and that gadget in the center is called a null corrector. We put a laser beam in that, take an image of the mirror, and then go grind the mirror down wherever it has to be to make it perfect. And so the failure review board, which I was a member of, by the way, discovered that a technician had made an incredibly simple and gross error in misspacing this. When he assembled it, he did it wrong. It's fascinating that the error was just enough to make the telescope useless, but not so large that it would be easily detected. And so the failure review board pulled this thing out of storage. I was there. We measured it. It was misspaced. End of story. And I'm thinking, thank God, it's finally not a management failure. It's a failure of one technical guy. Oh, great. I'm off the hook for that. Because this happened 5 years before I was on the program. The mirror was built. Well, the failure review board lead knew that there had been numerous other tests of this flight mirror with other instruments, and he looked into there and found that the contractor had rationalized all the other test results away. One by one they found some reason for neglecting all the other errors. And he tried to understand why that happened, and he realized that the project was driven by one requirement that is incredibly difficult. For Hubble Space Telescope to work, the body axis of the telescope has to point with a stability of 7,000ths of an arc second. Now, I know most of you don't think in those units, so 7,000ths of an arc second is the angle a US 25-cent piece makes at 320 kilometers, or it's the angle of a human hair at a mile. If we miss that specification by a factor of 10, the telescope would be useless, because what Hubble telescope did was take us from 2200 vision to 2020 vision of the universe. And if we built the best pointing system ever built, but still a factor of 10 worse, it would be a total waste. So you might imagine this is a systems problem, and it took lots of engineers and lots of people looking at every piece of the telescope, lots of time and money, and we had constant overruns. I'm talking about overruns of $400 million at a time. The telescope was originally budgeted for about $400 million. The first overrun was $400 million, got my boss fired and got me the director's job. We had 2 more overruns of $400 million each, and somehow I managed to escape being fired with those. But our normal habit is we look at where the mistakes are happening, and they're happening at the place that's doing the work, which is the contractor plant. So we incessantly beat on the contractor and showed them no appreciation. And in that climate, the management was not motivated to go look for hints of other problems. This thing was so hard to build. Then he said, the head of the failure review board said, now what I want to understand is why the smart scientists on NASA's science working group, who knew about spherical aberration because they're ground-based astronomers, why they didn't go and run this problem down and fix it. So I just can't understand how this happened. Then he learned that Perkin-Elmer never told NASA about these problems. This is an incredible finding that we never knew. I remember being in meetings where I saw these interferograms with parts of them blacked out, and I said, why is that blacked out? And they said, well, you know, it's an optics thing you wouldn't understand, and blah, blah, blah. And I said, well, I've got a PhD in physics, give me a try. But I never did penetrate it, never did get it. So when he got through, though, and he tried to go, when he went to report to the Congress about how we spent 15 years and $2 billion, which would be about $8 billion today, built a telescope that was useless, he said the root cause was a leadership failure. NASA created an environment that was so hostile that the contractor did not work problems they were not absolutely sure were real problems, and didn't tell NASA about problems, because every problem that wasn't real got them beaten up by NASA. Wow. A leadership failure, and I was the leader of the team. How do you think that made me feel? You know, actually it didn't bother me a lot, because at the time I didn't understand about the social causes of failure, didn't know how leadership failure could have done this. Nobody else did, and nobody blamed me. They should have, though. Today, we would say it's a team social context failure. Unfortunately, at that time, those words were not available. No one was using that kind of language. Once again, a national disaster caused by a social context that they named leadership. You see the pattern here. Just to give you some sense of what the environment was like of being in charge of this program and having this kind of thing happen, we had congressional hearings where I was beat up by by congressmen. Hearings is the wrong term. There's no one hearing in hearings. I went to, I avoided the late night comedy. That was awful. So one day I decided to go and relax with a movie that I thought couldn't be a problem, Naked Gun 2.5. There's a scene in there in the Blue Note Lounge, and but before Hubble launched, I was able to do interesting things with my position. For example, I was able to commission artwork. So I had an artist paint an artist concept of Hubble on orbit that hung in my office. So I'm watching this movie, and the camera pans along the back of the Blue Note Lounge, and there's a picture of the Titanic sinking, Hindenburg on fire, and the picture from my office with Hubble Space Telescope. There was no escape. The trauma that surrounded this was horrible. You can read much more about it in my book, or listen to podcasts or read papers on my website. But in the middle of that trauma, it occurred to me that there was no way to get out of this mess except to fix the telescope. And I didn't ask for this role, but nobody was in the position to go and take this project on and mount the servicing mission except me. So despite explicit direction from the head of our Congressional Appropriations Committee and the NASA administrator, I went ahead and started the servicing mission on my own in secret. And of course, it all worked out, as you surely know. Here's the same galaxy again, M100, Messier 100, before and after the correction. The image on the left is the same one I showed you before. The image on the right is after the fix. It's actually much more stunningly beautiful than the thing that's reproduced on this computer. And as you know, Hubble Space Telescope today is in its 20th year of successful science operations and regarded an unprecedented success by everybody. Okay. This is a fascinating case study, Korean Airlines. Korean Airlines was crashing at 17 times the normal rate for international airlines. I'm talking crashing 747s, not little planes. It got so bad the president of Korea would not fly on Korean Airlines. What erroneous assumption do you think caused this to go on for years and years? What mistake did they make? The mistake they made was they assumed it was about individuals' abilities and not social context. So why would they make the assumption about individual abilities? Because it's been drummed into our head through the university system year after year after year. You go study, you learn how to do it, you practice, that's all that's required. And so they kept testing the Korean Airlines pilots, and nothing was the matter with them. They fly as well as any pilots in the world. So it was a complete mystery. Finally, a little company called Alaton put observers in the cockpit to watch what happened in flight. And what they saw was when the captain was flying the aircraft, the first officer would be embarrassed to point out little mistakes he was making, so just stopped paying attention. So sometimes the airline would be flying along, captain's driving, first officer's reading a magazine. Well, modern jet aircraft require two people actively working to pilot them. I listen to the air traffic control on United Airlines a lot, and typically the captain flies the plane, or the first officer flies the plane, and the other one runs the radio and runs the avionics and does all the navigation work and all that. What they had done is they had brought Confucianism, which is very powerful in Korean society, the social context of Confucianism, into the cockpits. Then the problem was actually made a little bit worse. A 4G network provider in Korea, who heard me talk about this, said, "Charlie, you know, at the time this was going on, all of the pilots and first officers, all the captains and first officers were also trained in the military. There was a rank differential too." So what they did a very interesting thing. They went to the airline and said, we can restore safe flight, but here's what you got to do. You got to demand that everybody speak only English in the cockpit, and if they don't want to learn English fluently, then they can't fly. And the airline went along with it. Why did this work? Well, because when they were speaking English, they were able to drop their Korean culture. If they went back to speaking Korean, they went back into the habits of their culture, and the Confucianism crept back in. And today, there's a thing called crew resource management. All pilots are trained in it. It's interesting. It emphasizes interpersonal abilities over technical knowledge and skill, because the airlines get it. For safe flight, you have to have a healthy social context, and that's the same one that we developed for our teams. Okay, is this fun? Let's take a look at Fukushima reactor number 1, called Fukushima Daiichi. This is interesting because this tragedy is big for the nation of Japan. There are 50 nuclear reactors in Japan, provide 30% of its electricity, and I think only one or two are operating today, and the alternative is to import liquid natural gas, and you can guess how expensive that must be. So let's see what the root cause of the explosion and failure of that nuclear plant was. Was it the tsunami? That's what's been reported in the news. The tsunami flooded the backup generators. Was it the earthquake itself? There are also reports that the reactor was damaged before the tsunami came. Is that what it is? Or do you think the individuals, the Japanese who were running the thing, weren't adequately technically educated or committed to safety or whatever? What do you think it's about? Fascinating. Only about a month ago, after extensive study, the official failure review board in Japan reported that the failure was man-made, avoidable, and contextual. And they itemized all these items that are common aspects of Japanese society: reflexive obedience, reluctance to question authority, yada, yada, yada. So the answer to this is that Japan's reactors are not going to be safe, I don't think, no matter what they do, until they let us come in and do something similar as what they did with Alathon did with Korean Airlines and change the context in the reactor plants. It's too bad this has happened, but that's where we are. You're seeing a pattern here. Let's get out of these complicated things: nuclear reactors, airplanes, space missions. Let's look at everyday life, and I want to ask you, would you unconsciously and automatically change your behaviors in each of these contexts? How about giving or receiving a marriage proposal? How about having dinner with the fiance's family? How about your bachelorette party? Or suppose you're hijacked on your honeymoon. Moreover, if you didn't alter your behavior to fit this context, would you be sanctioned? At the fiance's family dinner, would you get a kick under the table? At the bachelorette party, wouldn't they pressure you to drink more? If you misbehaved on your honeymoon in a hijacking, wouldn't you likely get killed? Of course you would. So let's take a look at how we can make the invisible fields, the invisible social context, visible. See, I don't buy what Diane Vaughan said, that they're forever invisible. I'll show you how we do this. But let's bypass with little experiments. Suppose I put a bar of metal on the table in front of you and said, use your hands and tell me whether that bar is magnetized or not. Could you tell? I think likely not. What you might do is recall back to the 3rd grade where you took a bar magnet and you put a piece of paper on it and you sprinkled some iron filings. You tapped on the paper and voila, you can see the field lines. And probably a clever person today could write a software program and analyze that image and get an estimate of the dipole moment and so forth. So what we've done here is we've used a ferromagnetic material, iron particles, to trace out the invisible field lines of a magnetic field. What could be used to see the invisible field and the nature of it with team social context? Let's go back to the previous slide. The way we do it is we measure and then manage the behavioral norms of teams. 8 of them, 2 per dimension. I'll explain in the next segment why we organize it this way. You with me? Good. So think about this. If it was a beneficial thing to align ferromagnetic particles, would you align the particles one at a time with a tweezer, or would you rather change the alignment of all the particles at once with an aligning field? Well, I think the answer is quite obvious. You'd use the field. You'd put a coil of wire, put a current through it, line the particles, boom, boom. Okay? Now, let's imagine that the particles get jostled and get out of alignment, so you've got to come back every so often, like every 3 or 4 months in the case of our assessments, which do the same thing, and align the particles again. So I want you to see the analogy between developing people one at a time with a tweezer, or as a whole unit by changing the field they're immersed in, and hence their behaviors. How do we normally develop people? When I was going to these programs, when I worked as an executive, it was almost always unassociated people in some remote site in a classroom format. Well, if you look at how adults learn, what's interesting is we forget 90% of everything we learn within 30 days. It doesn't last. When we're talking about the only thing that matters here, behavioral change and not mere knowledge, it's much more difficult and much highly inefficient to do it this way. Moreover, things that you learn in one context don't transfer to the other. For example, when I went away to these classes, my staff told me they would get together in my absence and organize and form a phalanx of resistance, because what they knew was that anything that I learned in one of these events off-site and brought back, that if they could disabuse me from those new ideas for maybe a week or 10 days, I'd forget all about them. And they were right. It didn't work. You may have had this experience in other ways. I was in Africa once, and I was in a very primitive site, and there was this mask that might have been made of human materials. I'm not sure. It's fascinating to me. I bought it, took it home, and I walked in the door, and my wife said, "If you think you're bringing that in this house, you're crazy." The context where it looked so cool in that little rustic primitive camp didn't work in our house. Or you may have done this. I've done this. You go to a French restaurant, and it's a beautiful day, and you're looking at the scene, and you're having this marvelous meal, and there's this pretty pricey but delicious wine. You say, "Boy, this is so good. I'm going to take 2 bottles home." So you pick up 2 bottles, you take them home. A month later, you open them up and say, "My God, I paid that money for this. This stuff's terrible." It does not work between contexts. I want to talk to you now about what a team is, because what I'm interested in is a team from a social perspective. A team is a group of 2 or more people under a leader's influence interacting sufficiently to develop common behavioral norms. So let's look at an example. Is a doctor's office a team? Does it meet this test? Yes, even though no one does the same task. In a U.S. doctor's office, you come in and the receptionist greets you, and then someone else does your blood pressure and weight, and someone else talks about the problem you're having, and then finally the doctor comes, and then you go to the pharmacist and get the drugs. Everyone in there is doing a different task, yet it is the personality and nature of the doctor, who typically owns the practice, that drives everyone's behaviors. So I can go into a doctor's office and sit there for about 10 minutes and tell them whether they're going to have a successful practice or not by my experience of the social context they're creating. That's the team. Fun example. Think about someone asking you to join a SWAT team. Would you be willing to join a team unless you knew the behavioral norms? Would you be willing to risk your life if you didn't think that someone was covering your back? No, of course not. And then we do a whole lot of work with teams that are in a broken, larger context and having trouble functioning. This can happen when business base is falling, when layoffs are imminent. In the case of the NASA work, when the space shuttle program was being shut down, and we still needed the teams that managed the flight to be high performance, or when NASA decided they couldn't afford the moon program, we needed to transition the teams over into new things. So we're very good at this. We're very good at taking teams, working with them intensely, and making them have a little isolated social context of high performance, just like that pretty warm house in the middle of the winter in that picture. Okay. Now, I did a workshop some years ago with a bunch of people, and one of the guys who was in the workshop said he had a big project he ran. He said, "I'd like you to come do a workshop for my team." And I said, "Okay, now you were in my workshop before. Is there anything that we missed?" He said, "Yes, we never addressed the elephants in the room." And I said, "Aha, well, we're not going to make that mistake again." So now in every workshop we work with a team. We have them go through a process to write the unpleasant truths they must address, put them on 3x5 cards. We collect them, we organize them, it's all anonymous. Then we present the next day an organized version of this. Usually we get it typed up by the hotel overnight, or if not, we put it on flip charts. And later we prioritize them and pick out a high priority unpleasant reality, and we all process it together using the context shifting worksheet, as you'll see later. Very important step. Just want to show you another process chart. It's called AMBER. I mentioned it before. We bring your attention to things you're not used to thinking about, and the expression that underlies this: where attention goes, power flows. Mindset, you'll see, is at the core of everything. It's your platform for action, your mindset or attitude. We shape and change mindsets to make the behaviors work and be efficient. Then we practice the behaviors, and just a little fun thing I like from Stephen Covey: you can't talk your way out of what you behaved your way into. And everything's designed so you get a positive result, a positive business result, a positive emotional result, and a good experience from this behavior. This is the feedback loop that circles around over and over in our work to create the only thing that we think matters, which is, in the end of the day, behavioral change. So what's coming up next? We're going to look at how you begin to analyze these invisible forces so you can see them with a Jungian coordinate system. We're going to take a quick look at assessment benchmarking, how it works, and your results if you did a team development assessment. And teams that come into our workshops always do. We do a team development assessment before we agree to do a workshop, because we don't workshop bottom quintile teams. They got to be fixed with consulting first. Take a look at your team's innate personalities, the ones you were born with and carry you through life, and see how they match to the work your team does. We're going to use an analogy to handedness. It's very much like whether being born right-handed or left-handed. You're going to do this by looking at your innate. That means born deciding preferences, and we all have a preference for either emotions or logic to make decisions. Information preferences, intuition, or senses, and I'll explain all that. You're going to take a little brief test. It's very short. It's very accurate. Marvelous thing. We're going to take a look at some examples of people who use their innate strength to succeed, and when they're in jobs that don't match it, they've failed. This is where we've just been. These four big catastrophic accidents, the magnetic field metaphor, the simultaneous context-driven leader development, identifying elements, and the Amber process. That's it for this session, session 2. Session 3 will be up next. Thank you so much for listening. I appreciate your time and your engagement with 4D processes, and have a wonderful day, and I'll see you again on the next set. Take care. Bye-bye.